Hey everyone. Today we're diving into something pretty wild about our own bodies. It's a rule you definitely learned in school, but it's got this massive exception, and it's hiding right in plain sight, inside your chest.
Okay, so let me ask you something. You remember this from biology class, don't you? Arteries carry the good stuff, the oxygen-rich blood, and veins carry the oxygen-poor blood. Simple enough. That's the rule we all know, yeah? And yeah, for the most part, you'd be totally right. I mean, this is basically lesson number 1 when we learn about the circulatory system. You've seen the diagrams a million times, I'm sure. Arteries are always colored red, right? They're taking that fresh, oxygenated blood away from the heart to everywhere else. And the veins? They're blue. They bring all that used up, deoxygenated blood back home to the heart. It's simple, it's clean, it makes sense. But what if I told you there's a huge part of your body where that rule gets completely, totally flipped on its head? Yeah, not always. That simple red and blue rule, well, it's not the whole story. We've got some major rule breakers, some rebels, inside our own circulatory system. And here they are, our two main culprits, the pulmonary artery and the pulmonary veins. These are the big vessels connected to your lungs, and trust me, they do not play by the same rules. So what is really going on here? How does this work? All right, to really get this, we kind of have to forget that old rule about oxygen for a second. Let's learn the real definition of arteries and veins. And you know what? It's actually way simpler. So check this out. An artery is any vessel that carries blood away from the heart. That's it, full stop. It's all about direction. The cargo, whether it's oxygen-rich or oxygen-poor, it doesn't matter one bit. And you guessed it, the same exact logic works for veins. A vein is simply any vessel carrying blood toward the heart. Again, forget the oxygen, it's all about which way the blood is flowing. I love this analogy, it makes it so clear. Just think of your heart as a big city's downtown. Arteries? They're the on-ramps and highways leading away from the city. Veins? They're all the roads leading back to the city. The type of cargo on the trucks, the oxygen, doesn't change the name of the highway, does it? Of course not. Okay, so with that new rule in mind, let's actually trace the path of blood on its little road trip to the lungs and back. You're going to see how our so-called rule breakers actually make perfect sense. So here we go. Step 1. Oxygen-poor blood leaves the right side of the heart. Now, because it's moving away from the heart, what does that make it? It has to be an artery. That's the pulmonary artery. Then in step 2, the blood goes to the lungs, gets a full tank of oxygen, and now for step 3, it has to get back to the heart. Since it's now traveling toward the heart, it's in the pulmonary veins. See how that works? The names make perfect sense when you use the right rule. And from that point, the whole cycle continues just like you'd think. That fresh, super oxygenated blood that just came back from the lungs gets a huge push from the heart and is pumped out to the rest of the body. And it does that through the aorta, which is, you got it, the body's biggest artery because it's heading away from the heart. So you might be thinking, okay, cool fact, but why does this actually matter? Well, it's because it gives us a much smarter, more accurate way to understand the incredible design of our own bodies. Let's just put it all together in one place. This chart really lays it all out perfectly. That old rule we learned, it only works for what's called the systemic circuit. That's the blood going to your arms, legs, brain, all that. But the pulmonary circuit, the one for the lungs, it's a complete mirror image. So the real takeaway, the one thing to remember is this. Arteries carry blood away, and veins carry it toward the heart. That's the real rule. The exceptions only seem like exceptions if you're using the wrong definition to begin with. It's just such a great reminder that biology is filled with these super elegant and sometimes complex solutions, isn't it? It really makes you wonder, what other simple rules that we all learned back in school have these amazing exceptions just waiting for us to discover? Thanks so much for diving into this with me.